This is the 7th video in our solution series where we're talking about our second mathematical way of expressing concentration, which is called molality. In the last video, I showed you two beakers, and one was like a pale blue and one was a darker blue. Actually, which one was more concentrated? And based on what you know about Kool-Aid, you probably said the one that has a dark color. Well, it's not enough to say lighter and darker, so we were talking about the mathematical expressions. Now, the problem with molarity is it is moles of solute over liters of solution. But you know, if you take water and you make it cold, if you put it in the freezer, it expands, and if you heat it up, it contracts, which is opposite of what things usually do. But volume is temperature dependent. Sometimes we need an expression that is not temperature dependent, and that is why we would use molality. So we define molality as moles of solute. So we start off the same way. We're still going to use our moles of solute, but this time we're going to go over the mass of the solvent. So that's not going to change with temperature, mass of the solvent, and that has to be in kilograms. Well, you might be thinking that sounds really complicated, but remember, most of the time our solvent is water. So this is usually water. And we know, we learned back at the beginning of the year that 1 cubic centimeter is equal to 1 milliliter. And then we also learned that for water, 1 milliliter is equal to 1 gram. So if I have 578 mils of water, that's going to be equal to 578 grams. So it really does become a pretty easy conversion. The symbol for molality is in italics lowercase m. So we're going to see this lowercase m. If you see the capital M, you're talking about molarity. You see the lowercase m, you're talking about molality. So it's important to know the difference. All right, on to the sample problems. What quantity in grams of methanol is required to prepare a 0.244, and we say molal, which is a weird word. Everybody say molal solution in 400 grams of water. So they're asking me for grams, but I have molality on here. So what I like to do, the first thing I do is I'll write out my equation. Molality is moles. And right now I'm going to write it out long form, kilograms of solvent. One of the things that students have trouble doing with this is remembering what's your solvent and what's your solute. Guys, it is, let me get my red pen out here. Our solvent is usually water. So if you see water, you know, okay, that's probably going to be my solvent. All right, now I'm going to do a variable bank. So molality, I've got lowercase m, I've got moles, and I've got kilograms of solvent. So it tells me that my molality is 0.244, and it tells me I have 400 grams of water. So it doesn't tell me, I don't have to convert milliliters to grams. This would be 400 milliliters, but for this one. But notice this is in grams, and I have to go to kilograms. If you remember, I had kilo, hecta, deca, base, deci, centi, milli. Whoops, I'm off screen. Well, I'm starting here, and I want to go to kilo, so I'm going to go 1, 2, 3. So this becomes 0.4 kilograms. And then I can solve for moles. So when I set up this equation, I get 0.244 equals my moles over 0.4 kilograms. And when I solve for moles, I get that the moles are 0.0976. But the problem asks me for grams. So now I'm back to doing that mass to mole conversion. Again, I told you guys back at the beginning of the year, this is going to come up again and again, and it really does come up in almost every chapter. So I'm going to start out, I have 0.0976 moles. I'm going to put that over 1, and I want to go to grams. So I'm going to need molar mass. Carbon is 12, hydrogen is 13, 14, 15, 16, and then oxygen is going to be 16. So my molar mass is 32. So I have 1 mole of methanol, CH3OH, is 32 grams. And when I multiply, I get 3.12 grams of methanol. Right, next one's a sample problem. Take a crack at it. Okay, let's go ahead and hopefully you pause the video and try to work on this. So for this one, what is the molality of a solution containing 18.2 grams of hydrochloric acid and 250 grams of water? So again, we're doing molality. Is moles over kilograms of solvent. This is solute. So I've got molality, I've got moles, and I've got kilograms. What is the molality? Well, I'm solving for that. The kilograms I have, again, it gives me in grams instead of giving it to me in mils, but I could convert this if it said 250 mils, I would have to put a 250 down here. Remember, I have to change this to 0.250. Well, what they want is they want me to solve for this, but I don't have this. But if I have mass, I can do a mass to mole. So I'm going to have 18.2 grams of HCl over 1 times the molar mass. So chlorine is 35.5, hydrogen is 1, so this is going to be 36.5 grams of HCl in 1 mole of HCl. So 1.2 divided by 36.5 gives me if I round that, 0.5 moles. So now I bring that 0.5 over here and I can solve. So molality is moles divided by kilograms. I'm going to try to write this down here. Molality is going to be 0.5 over 0.25, which is going to give me 2 mole. You just write 2 with a lowercase m, but it's set. We express this as 2 molal. 2 molal. All right, and that's molality. And you'll see with all of these that you've got to often do that mass mole conversion. So what are our takeaways? Our second unit of mathematical concentration is molality, moles of solute divided by kilograms of solvent, which isn't too bad of a deal because 1 mil is equal to 1 gram. You do have to make sure you convert to kilograms. Here's my formula. In this case, I solved for my moles, and then I had to convert this to grams. Or conversely, I can I have to convert to moles, and then I bring that over and I can solve for either volume or molality. So you need to be able to work it both forwards and backwards. All right, that is the end of our mathematical concentration. The next thing we're going to look at are dilutions. Okay, that's all for now.